Hello children, welcome to Math Park. Today we are going to solve the problems on reciprocal graphs. We have just done with the quadratic graphs, now the reciprocal graphs, and the further we are going to do cubical graphs as well. So after going through this video, if you like it, please share with your friends, and if you are new to the channel, please subscribe. So we understand what are reciprocal graphs first. Reciprocal, as the name suggests, x and 1 upon x are the reciprocals. So reciprocal graphs represent the reciprocal functions typically of the form y is equal to a upon x and have a characteristic shape called hyperbola with two distinct branches. These graphs have a vertical and horizontal asymptote, which are lines the curve gets infinitely close to but never touches. For the basic function y is equal to 1 upon x, the asymptotes are x and y axis. Let's understand the key characteristics of reciprocal graphs. First, it is hyperbolic in shape. It consists of two separate smooth curves or branches. Asymptotes, there are vertical asymptote, a vertical line that a graph approaches but never crosses. For y equals a upon x, the vertical asymptote is at x is equal to 0. Horizontal asymptote is a line that graph approaches as the x value gets very large, positive or negative. For y equals a upon x, the horizontal asymptote it has y is equal to 0. There are no x and y intercepts. That means the graph of y equals a upon x never crosses x-axis or y-axis. The graph of y equals 1 upon x is symmetrical about the line y is equal to x. For the constant a, if a is positive, the branches are in the quadrant 1 and 3. This is the first quadrant, this is the second quadrant, this is the third quadrant, and the fourth quadrant. So if the a is positive here, 6 is positive, the branches are in the quadrant 1 and 3. And if it is negative, the branches are in the quadrant 2 and 4. Okay, the larger value of A, this is absolute A, makes the branches steeper and further from the origin. Let's start with the first question. Complete the table for y is equal to 12 upon x and draw the graph of the function. So 12 is positive. The value of x is minus 12. 12 upon minus 12 is minus 1. 12 upon minus 12 is minus 2. 12 upon minus 4 is minus 3. 12 upon minus 2 is going to be minus 6. 12 upon 1 is 12. 12 upon 4 is going to be positive 3. 12 upon 6 is going to be positive 2. And 12 upon 1 is 1. Let's plot this graph. So we have the points here plotted. And then we draw the smooth curve passing through this. And this is how you can see that when A is positive, you can see the graphs are in first and third quadrant. So simple, free, smooth and curve is to be drawn. Do not forget to label the graph y is equal to 12 upon x. The simple question. Let's take one more. And also remember, there is no value for x is equal to 0 because 12 upon 0 is again not defined. Division by 0 is not defined. Let's complete the graph. First, the table for y equals x square plus 6 upon x. So putting the values, some of the values I have put here. Now let us calculate. So x is equal to minus 3. We put in place of x minus 3 here. Minus 3 the whole square plus 6 upon minus 3. Minus 3 square is 9 and 6 upon minus 3 is minus 2. 9 upon minus 2 you get this as 7. X is equal to 0 0.5. So 0 0.5 square upon 6 upon 0.5, which is 0.5 minus 12, which is minus 11.25. If x is 1, 1 square plus 6 upon 1, so which you get it as 7. If x is 3, 3 square is 9 and 6 upon 3 is 2. So this is how you get this as 11. Let's put the values in the table and we start drawing the graph. So here is the x-axis and y-axis. You have chosen a scale because the values are ranging to up to 17.5 highest is there. So we took the scale on y-axis from 0 to 10. So here you have your 5. Here you have your 15. There is minus 3 here. Minus 1. 1 and 3. So, if we show everything, it becomes very difficult to, the plot, it becomes clumsy. So with a gap, I have shown here the on x-axis and y-axis. Let's plot the points here. So this is the point here, 4 and 1 point, minus 4 and 14.5, minus 3 and 7, minus 2 and 1, minus 1 and minus 5, and 0.5, minus 0.5 and 11.25, minus 11.25. For the positive values, let us plot. So we have here 1 and 7, 1 and 7. Then you have 0.5 and 12.25, 2 and 7, 3 and 11, 4 and 17.5. Let us draw the freehand curve over here. And this is how our reciprocal graph is ready for y is equal to x square plus 6 upon x. Got it? Let's take one with the negative values. Again here, there is no value for y when x is 0 because 6 upon 0 will be not defined. Let's solve one question with y is equal to minus 6 upon x. So put the value of minus 6. Minus 6 upon minus 6, you get this as positive 1. Minus 6 upon minus 4, you get positive 1.5. Minus 6 upon minus 3, you get this as 2. Minus 6 upon minus 2, you get this as 3. Minus 6 upon minus 1 is 6. Minus 6 upon 1 is minus 6. 2 upon minus 6 upon 2 is going to be minus 3. Minus 6 upon 3 is going to be minus 2. Minus 6 upon 4 is going to be minus 1.5. And minus 6 upon 6 is going to be minus 1. And let us plot the graph for this. Here is the graph for you. Minus 6, 1, minus 4, 1 minus 1, 1.5, minus 3, 2, minus 2, 3, and minus. And for the positive values here, for positive values of x, 1, minus 6, 2, and minus 3, 3, and minus 2, 4, and minus 1.5, and 6, and minus 1, and this is the graph ready. Okay, so whenever the value of a, the coefficient of the a is negative, you will get the graph in the second and fourth quadrant. So if you feel this video was helpful, please share with your friends. And if you are new to the channel, please subscribe. Thank you for watching.